This activity should have led you to, which we're going to talk about, is what we call the triangle inequality theorem. This whole section is just about one theorem, for the most part. Okay. And what the triangle inequality theorem says is that if you add the sum of the lengths of any two sides of a triangle, it's greater than the length of the third. No matter which two sides of a triangle you pick, if it's greater than the third in every possible case, it makes a triangle. Not a right triangle, because that's Pythagorean theorem, right? But it makes a triangle. So if you look at that sheet that we did, the first one was like a 1, 2, 5, right? If you add 1 plus 2, that's 3. That's not greater than 5, so it doesn't make a triangle. The second one we did was, I think, 2, 5, and 7. 2 plus 5 is 7. 7's not greater than 7, the third side. Wouldn't make a triangle. Closer. But no matter which two sides you pick, they have to add together to be larger than the third side. Of course, if you pick the 7 and 5, that would add together to be larger than 2, but it's got to work every way. You pick any two sides of the triangle, adds up to be greater than the third. If that's the case, it does make a triangle. If it's not the case, it doesn't make a triangle. Okay. If you want to find out if it's a right triangle, you have to use Pythagorean theorem. But that's what the triangle inequality theorem says. Add any two sides of a triangle must be greater than the third. Problem like this where it says determine the measures. If these measures, 6.5, 6.5, 14.5, can be the lengths of a triangle. Well, I know if I add 14.5 and 6.5, it's going to be greater than 6.5, right? If I add this one to this one, it's greater than that one. The one that I got to check is 6.5 plus 6.5 greater than 14.5. Is that true? Yes. 6.5 and 6.5 is 13, right? Is 13 greater than 14.5? No, so it is not a triangle because two of the sides don't add to be greater than the third. The easiest way to check is to pick the smallest two sides and add them together. Okay. This would not be a triangle. You could try and draw it if you want. You can do the spaghetti noodles if you want. But our theorem tells us if you add two sides, they have to be greater than the third to make a triangle. What's that? By 4. Oops, this came up. It's 6.8, 7.2, 5.1. If you add any of the two, it's always greater than the third. If I add these two, it's greater than 5.1. If I add these two, greater than 6.8. If I add 6.8 and 5.1, greater than 7.2. This could make a triangle. Doesn't matter if it's 0.1 greater than, if it's 1/10 greater than the other side, as long as it's greater than the third side, it makes a triangle. Okay. How about 6, 9, and 16? Can it be a triangle? It cannot because 6 and 9 is 15. It's got to be greater than 16, the third side. So this would be no. It's not a triangle. Okay. 14, 16, 27. That would be. 14 and 16 is 30. That's greater than 27. Of course, if you add 27 and 16, it's greater than 14. And if you add 27 and 14, it's greater than 16. Yeah, not too terribly difficult. That would be. Now, how about determining the possible side length? So I have this triangle, and I tell you PQ is 7.2, and QR, or sorry, I labeled that wrong. PQ is 7.2, QR is 5.2. Which of these cannot be PR? So if I add these two together, it's going to give me 12.4. So, of course, it cannot be 13. Because 13 is greater than 12.4. It could be 7, could be 9, could be 11. Cannot be 13. How about this one? Without labeling it, it would be, of course, D. Right? 6, 9 is 15. Added together. 15 is greater than 4, 9, and 12. Cannot be 16. Okay. The last little theorem in this chapter, not as important as a triangle inequality. Okay. Says a perpendicular segment, perpendicular meaning at 90 degrees, from a point to a line is the shortest distance from that point to a line. So meaning the shortest distance to get from P to this line is the one that makes a perpendicular, it meets it perpendicularly at a right angle, right? That distance from P to Q, P to Q is shorter than P to A, shorter than P to here, and shorter than P to B. The shortest distance from a point to a line is 90 degrees. Yeah, makes sense, right? Look at this proof, this inequality. This says, well, I'm going to give the proof, but it says choose the correct reason for this proof. So AD is an altitude. So automatically, because this is an altitude, what are we going to know about angle 1 and 2? You have to know what an altitude is, but what's an altitude due to the other side? We know these two add up to 180 because they're a linear pair, but since this is an altitude, what's it do to this side? What altitude is? Meets it at 90 degrees. Doesn't cut it in half, that's perpendicular bisector. Altitude meets it at 90 degrees. So automatically I'm going to know 1 and 2 are 90 degrees. So I'm just kind of talking out loud here, what do I know from what's given? What I'm trying to prove is that AB is greater than AD. Trying to prove AB is greater than AD. Only given this information. So let's look through this proof here. We filled in the steps. I did a whole formal proof here. You don't necessarily need to write this down. Okay. That's what we're given. We know because of an altitude that AD and BC meet at 90 degrees. Right? That's what an altitude means. We just said that earlier. So we know those are right angles. If you would have skipped this step and wrote those are right angles by definition of an altitude, I would be okay with that. Right? Because we know perpendicular lines form right angles. So that's really an unnecessary step in my opinion. You don't have to have that. Okay. Then it says angle 1 is congruent to angle 2 because all right angles are congruent. So we know those sides are congruent. Okay. We know that if they're congruent, they're equal then. The reason we changed it from congruent to equal so we can do some substitution if we need to. We know to go from congruent to equal, we just say definition of congruency. But now it says angle 1 is greater than angle B, angle 1 greater than angle B. How do I know that? Well, let's come back to that in a second. Well, then we know if 1's greater than B, okay, angle 2 is greater than B by substitution, because 1 and 2 are the same. Okay. Therefore, if 2 is greater than B, that's the angle opposite each of these sides. AB is greater than AD by that theorem. I think it's either 5.9 or 5.10 on your sheet, but it's wrote out into words here. If an angle is greater than the second angle, the side opposite that angle is longer than the side opposite the smaller angle. I think this is 5.9 or 5.10. Is it 5.10? Okay. What's my reasoning, though? This was the toughest part, to say angle 1 greater than angle B. Yeah, Eric?
It's the exterior angle.
Excellent. The exterior angle theorem. Remember when you have a triangle? Exterior angle inequality. That the exterior angle is greater than each of the two remote interior. Right? Remember that we talked about earlier in the week? So this angle 1, since it's the exterior of that triangle, is greater than both angle B and DAB. Okay. Very good. That's the exterior angle inequality theorem. That's what we talked about earlier in the week. Last theorem, we don't use that often. It's on your sheet, but we probably aren't going to use it. Perpendicular segment from a point to a plane is the shortest distance, just like from a line. To get from a point to a plane, the quickest way is to meet it at 90 degrees. Okay. And that's all we have for the triangle inequality section.